In today's notes, we're going to look at forces, rivers, and wind. It says when two or more forces act on a moving object, the object's actual direction and velocity correspond to the vector sum of the forces or the resultant. We've got three examples. We have the path of a helium balloon is affected by the rate at which it is rising as well as the speed of the wind. And so if you're holding the balloon, the helium is forcing it up, the wind is blowing from the west, so it's blowing in the direction of east. The actual path of the balloon is going to be on this resultant vector. Example B, we have a boat trying to cross the river, but the current is flowing south, and so the actual, the resultant vector is going to be kind of going in a southeast direction. In example C, we have the dog who's going after the cat. So his vector is going towards the cat, but the owner is pulling the leash back. And so the actual resultant vector is going to be going in this direction here. So it says when F1 and F2 are vectors for the forces acting on a moving object, R is the vector showing the actual velocity and direction. That's the resultant vector. And it says the direction is still a rotation angle measured from the positive x-axis. So we'll still be using our inverse tangent. The magnitude is associated with the speed or force, and we still use our Pythagorean theorem. So in example 1, we have the balloon rising, and they call it U. I'm going to go ahead and just write out, this is our balloon. And it's rising at 6 miles per hour. That is my magnitude. It's rising straight up, and so that direction is 90 degrees. The components of a vector that is just going straight up has a 0 horizontal and a positive 6 vertical. Now the wind, that's vector W. This is blowing from the west. Okay, so I'm just going to north, south, west, east. So if it is blowing from the west, that means it is blowing east. If we think about our rotation angle, that is going to correspond to 0 degrees. And so the direction is 0, 8 miles an hour. This is just going in a horizontal direction, so that's going to be 8, 0. Remember the components, we just add these down, so we get 8, 6. And the way this chart works is we're going to work down this column and then left. All right, so we need to find our direction. Direction is inverse tangent of the B value divided by the A value. And just remember, when our A is negative, we add 180, but in this case, 8 is positive, so we're good. And the magnitude is going to be the square root of 8 squared plus 6 squared. This is one of our Pythagorean triples. It is a multiple of the 3, 4, 5 triangle. If you want to work it out, though, that's 64, and 36 gives you a square root of 100, which is 10. All right, I'm going to go to Desmos to find my inverse tangent of 6 over 8. Okay, let's type in inverse tangent. And that's about 36.9 degrees. So the actual speed is moving at 10 miles per hour. That is the magnitude. And the angle that the path of the balloon is 36.9 degrees. Okay, in example B, we have the boat, and this is heading directly across a river. And let me just look at my little picture again. The boat is going exactly east. So our boat is traveling like this. Here's my little boat. And then the current is going exactly south, so the resultant vector is going to be this guy. Okay, so that just maybe helps me a little bit. This is the boat and this is the current. And so the boat is going directly across the river, 12 miles per hour, and that direction is 0 degrees. So that is 12 in the horizontal direction, 0 in the vertical. And the current is flowing at 17 miles per hour, and that is flowing exactly south, so that's negative 90. And so that has no horizontal, but it is 17 in the negative. So because we're going south. All right, add your components down. That's 12, negative 17. And then same thing that we did before. We have inverse tangent of the b value divided by the a. We don't have to add 180 because the a is positive, so we're good there. And then square root of the a value plus the b value squared. Make sure you're squaring the negative on that one. All right, so let's go back to visit Desmos. Okay, let's see. I'm just going to clean up this one, if it'll let me. All right, and so in this case, we had what, negative 17 over 12, and that gives me a negative 54.8 degrees. And then let's do our square root of 12 squared plus negative 17 squared. And I have a length of 20.8. So my magnitude is 20.8 miles per hour, and my angle was at negative 54.8 degrees. Remember, we're using the chart. This column down, we don't need this stuff anymore, and we work it left. All right, in the last example, we had the dog and the owner. And so this was my dog, and this was my owner. And it said that the dog is using 40 pounds of pressure. That's right here. And his direction was negative 90, so they're components. Nice. The owner, it says, pulls on her pet's leash with 78 pounds of force and at an angle of 120 from the leash. So in this case, 120 from the leash. Let's check out what that is. Okay, so this angle here is 120 from the leash. Okay, so what I'm also going to draw in is this is my horizontal and my vertical, my x and my y axis. So if this angle is 120, the angle that the owner is pulling is 30, because then right here you have your 90-degree angle. And then what we're going to see is the angle of the resultant vector is going to be this little guy right here. And so we're going to expect that the rotation angle of the resultant vector is going to be a very small number. Okay? So the rotation angle that the owner is pulling is 30 degrees. Okay, so to find my components, I can't just look at this and find my components. I actually have to do some math. And if you go back to day 1, to find the x component, it is the magnitude times cosine of the angle, and the y component is magnitude times sine of the angle. So I'm going to need to visit Desmos to find those guys. And then we'll add those down, do our inverse tangent, and then our magnitude with Pythagorean theorem. So let's go to Desmos. Okay, so we have 78 times cosine of the angle, and we have 78 times sine of the angle. Okay, so those are the components of the owner. So it's about 67.5 and 39. 67.5 and 39. And so let's just check this, because if you're not 100% convinced on that direction, that 30 degrees, let's look at our components. We need to be going to the right and up. Let's look at the vector for the owner. From tail to tip, is this vector going right and up? It makes sense. All right, so let's add down. 67.5 and negative 40 and 39 give you negative 1. So inverse tangent, the b over the a, that's what we'll put into our Desmos, and then a squared plus b squared. Okay, let's visit Desmos again. Okay, so I'm going to come back up here and just see if I can edit this guy up here. And so it's the B value divided by the A value. Okay, so yeah, look at that very small angle, negative 0.85 degrees. That angle, negative 0.85 degrees, less than 1 degree below the x-axis. And then let's find the magnitude of that vector. And this is, see if I can just edit this one, 67.5 and negative 1 squared. And that magnitude is 67.5.